This tutorial video is about similarity, congruence, and proofs part 2. That's the name of the unit that we're in. This video will help you perform better on the unit test. Let's do some random questions. A regular pentagon is created using the bases of 5 congruent isosceles triangles joined at a common vertex. The total number of degrees at the center is 360 degrees, of course. If all 5 vertex angles meeting at the center are congruent, what is the measure of a base angle of one of the triangles? Well, obviously we have 5 angles meeting here at the middle. Total of 360 degrees. So let's start by doing 360 divided by 5. That'll tell us the size of each one of these angles. So let's see, 360 divided by 5. Hold on, I missed. 360 divided by 5. That's 72. So that means each one of these angles is 72 degrees. Now, so let's just look at this triangle. I'm just redrawing it over here bigger. So this angle here at the top is 72 degrees. This is an isosceles triangle because these sides are the same. That means these angles, the base angles, are the same. We know that the total degrees inside a triangle is 180. So if we take 180 degrees, subtract the 72, let's see how much is left over. So if we do 180 degrees minus that 72 that we have, that leaves 108. So that means we have 108 degrees left to be shared equally between these two base angles. So if we take that 108 and divide by 2, that should be 54, yeah? Divided by 2, boom. So that means that each one of these base angles should be 54 apiece. And notice, if you add all these up, it should add up to 180. That's a way of checking your answer. So the answer should be the top answer, 54 degrees. Boom! There you go. Now, let's move on to the next one. Triangle KNM is shown. Check it out. What is true about the sides of K, N, and M? Well, because these two angles, K and M, are equal, they're both 25 degrees. That means the sides across from them are also equal. So this side and this side have to be the same. So KN and KM are congruent. This is probably obvious, but this base of the triangle must be bigger than both of the other two. So this side KM is bigger. KM has got to be bigger than KN, which equals NM. Okay, so these two are equal to each other, and this one is bigger than both of them. So let's see what's up. What is true about this? This seems like just straight multiple choice. So Kn is equal to Nm. Yep, we just said that. So that means the top one must be the answer. And there you go. Whoever did this particular test thought that the second one was the answer. So let's take a closer look at that. Kn plus Nm equals Km. So look, we know that Km is bigger, but there's no reason to believe that that this one plus this one will equal this one. And in fact, that's impossible, because if they were exactly the same, if I have a side over here, let's say that this was length 10. And then I had another side over here that was also length 10. And let's say that this base down here was 20. So this would be a situation where the left one plus the right one would equal the bottom one. Problem with that is you couldn't make a triangle out of it. 10 plus 10 equals 20. If you imagine that these are hinges, like you could swing them open wider or close them narrower. If you were to close these down, they would just barely meet. There'd be nothing left over to make a triangle. So these actually together have to be bigger than km. So you have enough material left over to make a triangle out of it. They can't be equal. They would have to be more. Like they would at least have to be like, maybe this could be 11 and 11. Now you could make a triangle. Otherwise it would collapse down to a straight line. So let's move on. Which pair of triangles can be proven congruent by SAS? Of course, SAS stands for side, angle, side. So let's see what we have. Look at this first triangle. This first pair of triangles. We have a side congruent to a side. Check. We have an angle congruent to another angle. Check. And we have this shared side, so obviously those will both be congruent for both triangles. So we have a side, an angle, and a side in that order. So this one is definitely good. Now if this is multiple choice, then that has to be the right answer. The rest of these are going to be wrong. But let's take a look anyway. On the next picture, we have an angle, a side, and an angle. So this would be angle, side, angle, not side, angle, side. We have two angles and a side. So that's definitely not going to be it. Look at this picture over here. We have a side, we have another side, and we have a third side. So this would be congruent by a side, 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 not side, angle, side, which is what we wanted. So that can't be the answer. Now this one down here at the bottom is close because I see a side and I see an angle and I see another side. So there's a chance that this could have been side, angle, side. The only problem is the order. Look at the side. So I have this side marked and I have this side marked. Okay, these are the sides. Now look where the angle is. If we want to do side, angle, side, the angle has to be in the middle between the two sides. Now guess what? That angle should be over here. This is the angle that's between the two sides. So this angle is the wrong angle. All right, this angle is off to the side. So this would not be side, angle, side. This would be angle, side, side. Oh God, that's a bad word. Got to erase that immediately. Let's call it side, side, angle, so it doesn't make a bad word. But luckily, this is not even a valid congruence. So it's impossible. So that's why it is not side, angle, side, because the angle has to be between the two sides for side, angle, side. So the answer is this one up here. So let's take a look at that. So that was a good guess. Whoever did this test and guessed wrong, hopefully you understand why it's not side, angle, side. The correct answer is this one over here. Okay, just in case you were thinking about like hypotenuse leg, because that's one that sometimes works when you have a right triangle, but notice how the hypotenuse is here, and we don't know anything about the hypotenuse, so that it wasn't hypotenuse leg. Alright, let's keep going. Consider this triangle right here. What statement about the angles is true? So we've learned that the bigger side is always across from the bigger angle. So let's make a list. On the left side, I'm going to put the sides, and on the right side, I'm going to put the angles. Okay, and we're going to put them in order from biggest to smallest. So the biggest side is 14. So that's going to go up at the top. The medium-sized side is 10, so I'm going to put that next. And the smallest side is 5, so I'm going to put that at the bottom. Now, let's match those up with the angles that are across from them. So if 14 is the biggest side, then x should be the biggest angle. Put that at the top. Next is the 10, and the 10 is across from angle W. So that should go next. And that leaves the 5, which is across from angle Y. So that should go last. So now we've put the angles in order from biggest to smallest, which should allow us to answer these questions. Which statement about the angles is true? Angle W is greater than angle Y. Well, yeah, that's true. These are in order from greatest to smallest, and W is greater than Y. So, yeah, that answer is correct. Let's look at the other three real quick. Angle Y is the largest? No. If it were, it would be at the top. Angle X is smaller than angle W? No. Angle X is at the top. It's the biggest. Angle W is the smallest? No. If it were the smallest, it would be right here at the bottom. So, kabam! The top one is the answer. Like I said. Let's look at the next one. If isosceles triangle ABC has a 130-degree angle at vertex B, which statement must be true? Well, seems like we need a picture, don't we? So, should I cheat and draw one using the software? I think I will. But if you were doing this test, you'd have to just draw it by hand. Alright, but I believe you could do it. Anyway, so here we have an isosceles triangle. That means these sides are the same and these angles are the same. So this is triangle A, B, C. So angle B up here is 130 degrees. Now what must be true? Let's go ahead and figure out what angle A and C must be. Now the total degrees in a triangle is 180. So that means all these have to add up to 180. So let's take 180 and subtract 30 and see what we have left over. So if we take 180 minus 130, because that's the angle we already know, that's going to leave 50 degrees. So that leaves 50 degrees to be shared between angle C and angle A. Alright, so these two, A and C, have to add up to 50 degrees. So that means they have to be 25 apiece. So that should be enough for us to answer all the questions. Angle A is 15 degrees. No, it's 25. These have to be the same. If the sides are the same, because they said that's what isosceles means. Alright, the sides here have to be the same. So these angles have to be the same. Angle A plus angle B is 155. No, that's nonsense. The total in a triangle is 180, so that leaves 50. So A and C... Oh, wait. I'm sorry. I was reading the question wrong. It says A plus B is 155. Okay, let's see. We have 130 plus 25. Yeah, that is 155. So that means this one is the answer right here. That's the answer. A plus C is 60? No, it's 50. We talked about that. Angle A is 20? No, it's 25. So the answer is the second one. And there you go. Alright, let's keep going. The lengths of the sides of triangle XYZ are in terms of variable m, where m is greater than or equal to 6. What is correct regarding the angles of the triangle? So they're saying greater than or equal to 6. So that means m, the smallest m could be is 6. So let's start with that and use that to answer the questions, because m could be bigger than that, but that shouldn't change the order of the sizes. You know, if angle X is the biggest, it should be the biggest no matter what size I make M. So let's go with the smallest it could be, which is 6, and let's plug that in and see what we get. So that makes this over here, that's 6 minus 3. And this would be 6 plus 8. And this would be 2 times 6 plus 3. Alright, so if we do that, then what we have is 6 minus 3, so that means this is 3. 6 plus 8, that's going to be 14. 2 times 6 is 12, plus 3 is 15. So this would be 15. So this question is all about the order of the angles. Let's see. Now this is a less than sign. So this is saying x is less than z, which is less than y. So these are in order from small to big. Alright, so let's put them in order from small to big, like we did on a previous question. So let's put the sides over here, and we'll put the angles over here. Okay, so at this point, I don't really need these calculations. So the smallest side is 3. Next is the 14, and next is the 15. So the smallest angle should be across from the smallest side. So if this is 3, 3 is across from y. So y should be the smallest angle. 14 is across from z. So z should be the middle sized angle. 15 is across from x. So x should be the biggest angle. So if I put these in order from smallest to biggest, it should go y, z, x. So here I have it, y, z, x. So this should be the answer right here. And there you go. Okay, this question is about a proof. See what we can do. So the proof that triangle QPT, okay, so just so you know, triangle QPT is this triangle shown here in blue, and that's supposed to be congruent to triangle QRT, and that triangle is this triangle over here that I just colored pink. Alright, so given that SP is congruent to SR, alright, that's these markings right here, prove that the blue triangle is congruent to the pink triangle. Alright, so now we have this proof with some missing reasons. So what is the missing reason in the proof? So really it's just right here, number 3. Alright, this one is not completely obvious, except for it's the only one of these 4 choices that's going to remotely make sense. Look at the previous step. They said that ST, the vertical piece here, is perpendicular to PR. And the reason that they gave was the converse of the perpendicular bisector theorem. So basically they're saying that if, let me change colors for a second. Basically they're saying if these distances are equal, then this line down the middle must be the perpendicular bisector. So they're saying, hey, what we have here is a perpendicular bisector, and that's why they said that these are perpendicular, because it's a perpendicular bisector. But then on the next step, they're saying PT is congruent to TR. Well, if we just decided that this vertical piece is a perpendicular bisector, then, well, guess what? A bisector cuts a segment in half. So of course we would have 2 equal pieces if it is in fact a bisector. So what we're talking about then is the definition of bisector. Okay, so that's definitely going to be my vote for the answer, is going to be this first one. Now, I'm more sure of that when I look at the other choices. For example, reflexive property. Reflexive property is when you have two things that are equal to each other. So if this was saying PT is congruent to PT, that's when it would be reflexive property. So I know it can't be that one because it's not the same thing twice. Definition of congruence. That's when they say, well, length PT is equal to length RT. So therefore, segment PT must be congruent to segment RT. This is the definition of congruence. All right, the distances are equal, therefore the segments are congruent. That's not what happened. If we look at the previous step, it doesn't say this. So it's not the definition of congruence. That just leaves substitution. And again, looking at the previous steps, substitution is just not what happened. Substitution would be more like this. If on the previous step it said something like this, okay, something like this is what it would take to be substitution. I'd need previous steps like this. If I knew that PT is equal to SR, and then SR equals RT, well then now I could do a substitution, couldn't I? Since PT is equal to SR, I could substitute, I could take out the SR and put PT in its place, and then I could conclude that PT is equal to RT. That's what substitution looks like. But there's nothing like that. The previous steps don't have these other things that I'm swapping out. It says something about perpendicular. It's a whole different thing. So substitution is not what happened either. So it definitely has to be definition of perpendicular bisector. All right, that one was a little bit weird, but what are you going to do? Okay, moving on. Could triangle JKL be congruent to triangle XYZ? And we have this information. Let me think for a second. All right, on further consideration, I now can say that no, there's no way these two triangles could be congruent. Because look where the 90-degree angle is, and the one side we know is the 10. On this triangle, we have the 90-degree angle, and across from the 90-degree angle is a side length 10. Now, if these were congruent, then it would be the same story on the other triangle. Across from the 90-degree angle, I would have a 10. Okay, and there's no way that you could have a 10 here and a 10 here. Okay, you can't have a 90-degree angle is the biggest angle in a triangle. So the hypotenuse here has to be the biggest side. So you can't have two sides that are both, you can't, the hypotenuse and another side can't both be 10. 10 has to be the biggest. So this wouldn't make sense. You could not have a 10 here, and you would have to have the 10 here to be congruent to the other one. So the answer is no. So we know it's not going to be any of these yeses. No, because the hypotenuse of one triangle is equal in length to the leg of another triangle. Well, yeah, that definitely sounds like what we just said. So I'm going to read the other one, but it's looking like this is the correct answer. No, because the leg of one triangle is equal in length to the leg of the other triangle. No, that's just not the case. It's what they said first. We have the leg of one triangle, this is a leg, is equal to the hypotenuse of the other triangle. Okay, they're not both legs. It's leg hypotenuse, so this is the answer. Okay, what do we have here? What is the length of segment NS? So here's the thing. What we have here are medians. So we have a midpoint connected to a vertex on all three sides. So when you draw a segment from a midpoint to a vertex, you are drawing a median. And when medians intersect, they intersect in a special way. By the way, this point S is called the centroid of the triangle. The centroid is the place where all the medians meet. But anyway, the relationship is this. The centroid is going to divide each one of these medians into a smaller part and a bigger part. So, for example, this is clearly the smaller part over here, and this is the bigger part over here. So what you need to know is that the bigger part is twice the size of the smaller part. Okay, so the blue, the big part is going to be twice the size of the pink. Okay, the big part is double the small part. So that means that the 7x minus 3 part should be double the size of the 5x minus 3 part. That's the key to this whole thing. So just solving this equation out. So I'll have my 7x minus 3, little distributive property over here, and we have 10x minus 6. Let's get these like terms together. So I'm going to subtract 10x from both sides to get these x's together. So that's going to give me, you know what, that might bug you. Let's see if we can keep it positive for a little while longer. So instead of subtracting 10 and getting negative 3, I will subtract 7x from both sides. So now I have negative 3 is equal to positive 3x minus 6. Now I will add 6 to both sides. That'll give me positive 3 is equal to 3x. Then when I divide both sides by 3, I find out that x is equal to 1 unit. Alright, now that's x. That's not what they asked me for. They want to know the length of segment NS. So segment NS is the blue piece. So NS is 7x minus 3, as you can see. So if I want to know how big that is, now I know what x is, so I will substitute that in. So that will be 7 times 1 minus 3, which is 7 minus 3, which is 4. So that's the actual length of NS is 4 units. So that's the answer. Okay, so just remember, when the medians meet, you have a small part and a big part. The big part is double the small part, and then you go from there. Okay, which congruence theorem can be used to prove that WXS, shown here, is congruent to YZS, shown here? Now we have the markings that we have. We have an angle and a side congruent to another angle and another side. We need one more thing. The thing that's missing is we have vertical angles. Whenever you have intersecting segments, they create vertical angles, which are always equal. There are actually two pairs, because these are also vertical angles, and they would also be equal. But back to this picture, our vertical angles are right here. So what we have are two angles, the vertical angle and this 90-degree angle, matching up with the other vertical angle and the other 90-degree angle. So we have two angles and a side in the middle. So that we have two angles, and then we have the side that's right between them. So that is angle, side, angle. Alright, so I know that this is going to be the answer right here. Now you see that's a right triangle, so you might have been tempted to say hypotenuse leg. But that H stands for hypotenuse, and the hypotenuse is like WS. We don't know anything about WS. There's no marking here. We have no reason to believe that WS and SY are congruent. We don't know anything about the hypotenuse, so that's why it is not hypotenuse leg. Okay, so don't assume just because you see a 90-degree angle that it's going to be hypotenuse leg. Look and see, does it actually involve the hypotenuse, or is it just a leg? Okay, couple more problems. We're almost done with this video. In triangle XYZ, X is 90 degrees, Y is 30. In triangle TUV, okay, I feel like we better start drawing some pictures first before we go any further. Okay, so they mentioned a 90-degree angle. So here is a right triangle right here. And now I've made two of them. Great. So let's see. Angle X is 90 degrees. So I'm going to make sure to make this angle X. So we have angle X, Y, Z. Angle Y is 30. So this will be 30. So I'll call this angle Y. So that means this must be angle Z. Alright, I feel like changing the color of this one to pink. Okay, so this is going to be my 90-degree angle. So we have, here comes triangle TUV. Angle U is 30 degrees. Alright, so I'll put angle U up here, just like the Y. Angle V is 60. So that will, I'll put that down here. Here's angle V. Which must be true. So this pink triangle is triangle TUV. So that means this 90-degree angle must be T. Oh, by the way, I said 90 degrees. They didn't actually mention anything about a 90-degree angle when they talked about TUV, but we know that all of these have to add up to 180. So if you add up the 30 and the 60 that they mentioned, that together that makes 90. So 180 minus 90 is 90. So you know the missing angle has to be 90. In a similar way, they mentioned a 90 and a 30 on the first triangle. They mentioned a 90 and a 30. Well, if we subtract those two from 180, which has to be the total, that's going to leave 60. So we actually know all three angles. All right, even though they didn't give us angle Z, we know it's 60 because it has to add up to 180. Even though they didn't give us angle T, we know it's 90 because that's what it takes to add up to 180. So now we should be able to answer any questions that they throw at us. First of all, are the triangles congruent? No, they did not give us enough information for us to know that these are congruent. All we have are angles. We know the angles are 30, 60, 90. We know that the angles are 30, 60, 90. We don't know anything about the sides. Now, when I created these, I sort of made them look congruent. But for all we know, we could have a big one and then a small one. We don't know. We don't know anything about the sides. Hold on. So the answer is no. No congruency statement can be made. There are exactly 5 ways to prove that triangles are congruent, and here they are. Notice that all of them involve sides. Side, 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 angle, side, angle, side, angle, 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 side. All 4 of these have the word side right in them. The only one that doesn't mention the word side is hypotenuse, leg. But guess what? Both of these are sides. All right, you still need to know congruent sides. 2 of them. You need congruent hypotenuse and congruent leg. Those are all sides. So there is no angle, angle, angle theorem here. And that's what it would take. So let's see. So we can throw out the first 2. So no congruency statement can be made because only two angles in each triangle are shown. Well, let's read on. No congruency statement can be made because the side lengths are unknown. Yeah, that's what you've been hearing me say all this time. You need some sides. So the answer is the last one. Okay, you need some sides, people. All right, I think this is going to be the last question in this video. Based on the diagram, which expresses all the possible lengths of segment AB? Okay, this is going to be a little bit interesting. So what I want you to do is picture this like it is a hinge. And then I want you to imagine that AB is made of rubber, like a rubber band. So you can imagine opening this wider or closing it in a more narrow way. If you open it wider, it's going to give you the biggest possible stretch of AB. So imagine that I took this and, okay, so here is segment CB. That's here on the bottom. Now imagine that I took this segment CA. Maybe I can do it if I do it like this. So the way it is right now, it's kind of like in this position. But imagine if I stretched it all the way. All right, let me take it to about there for a moment. Let me make it a little bit bigger and color it blue. So do you see how big this rubber band is? All right, that's getting pretty big. But imagine if I stretched it even further until it's all the way flat. All right, obviously if I make it flat, you can't make a triangle anymore, but this will give you an idea of the outer limit. So here is the point A right here, okay, that I've now stretched out wide open. So now this rubber band, so AC is 27 and CB is 54. So if I stretch this out flat, I have a total, all right, if I add these up, all right, 27 plus 54, that's 81. So that's the biggest stretch you could possibly get on this rubber band is 81. Okay, so that means AB has to be less than 81. Okay, so I'll put 81 up high. All right, so AB would have to be below that. Now let's go in the other direction. Let's close this thing down. So if I took this segment, okay, hold on, let me clean this up a little bit. All right, if I took this segment and I'm going to rotate it around the other way. So again, this is how it kind of is shown in the picture. Now if I close this, making it as small as possible. Now remember, this is 27, and this down here is 54. Now, this rubber band part, okay, that would be, because this would be A, that's going from A to B. It's getting close to being as small as it could be as we're making this smaller. We have a little bit ways to go. Now, if I flatten this out completely, you won't be able to make a triangle, but it will show us the smallest possible value of AB. So let me go ahead and do that. Okay, so whoops, didn't mean to do that. So imagine I take this 27 and I just flatten it right out, right onto the line. So now here is point A. And I'll put a little dotted line here to show the length from A to B. So look, if the big distance from C to B is 54, and the smaller distance from C to A is 27, what is the distance from A to B? You could subtract. All right, if you take the 54 and subtract 27, that must be this leftover distance from A to B. Okay, so if I do 54 minus the 27, oh, that's 27, of course. Okay, because those are equal. 27 plus 27 is 54. So AB would then be 27. So AB can never equal 27 because to get a length that short, you have to shut it all the way down to a flat line. So what we know is that AB must be somewhere between 27 and 81. It can't be as small as 27, and it can't be as big as 81. Okay, so in other words, well, let's look for that statement basically up here. So AB is less than 27? No. That's AB has got to be bigger than 27, so it can't be that one. AB equals 85? No, 81 was the biggest. Can't be that one. AB is 25? That's possible. No, no, that's false. AB equals 25. No, 27 is the smallest AB can possibly be. So there's no way that AB could be 25. So it's this statement right here is the only thing that makes sense, all right? This is basically saying the exact same thing as this. 27 is less than AB, which is less than 81. In other words, AB is between 27 and 81. And there you go. All right, I hope this video was helpful. I hope you took some notes. Give your test another shot and take your time, do it right. Good luck.